Honors Algebra 2 Pre-Calc. We're doing partial fraction decomposition, which is section 2.7 in the pre-calc book, but part of our chapter 6/partial fractions unit. Okay, so now we're going to talk about how to find the values of those unknowns that we put in the setup. So finding the values of the constants. So first thing you're going to want to do, and in a second we're going to walk through an example 3 right over here following all these steps. Example 3 is actually example 1a that we already did. We already found the setup. Now we're going to figure out how to find the actual values of a and b. So number 1, get a common denominator on your right-hand side that is identical to the original denominator. Now, I guess I put setup in right-hand side because I always set it up so that my setup is on the right-hand side and my original is on the left-hand side. I don't know why, it's just what I do. So, and again, in case you're unfamiliar, LHS is usually left-hand side and RHS is usually right-hand side. It's pretty common in mathematical proofs to see that notation as well. That's not just a Hoganism, that's actually a thing. So, what you want to do is on your setup side over here, you want to get a common denominator, but, and this is very, very important, you want that common denominator to be identical to the original denominator, meaning whatever common denominator I get over here had better be an x squared plus 4x plus 5 if I clean it up, right? Second thing I'm going to do is because those new totally equal denominators are the same on both sides, I can basically ignore them and say numerator equals numerator, which is helpful because now I won't have a fraction anymore. Then I'm going to use what I call clever substitution, and I'll talk you through that in a sec, to knock out some of the unknowns, allowing me to one by one find each of the values. Sometimes, in a really hard version of these questions, you might have to use a system of equations in addition to what I'm talking about, and we'll cross that bridge when we come to it. There will be some harder versions of these problems. Lastly, make sure that you rewrite your setup with the numerical values for a and b, because at that point you're going to know what a is, like a is going to be a number and so is b, and you need to make sure you rewrite your final answer with those numbers. Certainly when you get to BC Calc and have to do this whole setup thing is only the precursor to the actual calculus part of the problem, but for right now this is our whole problem, so let's just worry about that. Okay, so let's walk through these steps one by one. Sorry, you do need to see this. Okay, so step 1, I need to get a common denominator on the right-hand side that looks exactly like this, okay? So what I say to myself is, oh, this is actually the product of these two, right? This is an x, and in fact, if you want to go a step further, we can actually just remind ourselves that this, when we factored in example 1a, was an x plus 4 times an x plus 1. So I look and I say, okay, cool, I get it. This guy has the x plus 4, but he's missing the x plus 1, so I'm going to have to multiply him by x plus 1 over x plus 1, right? Meanwhile, this guy has the x plus 1, but he's missing the x plus 4, so I'm going to multiply him by x plus 4 over x plus 4. What I want you to notice about this now is that all of these fractions have identical denominators. X plus 4 times x plus 1, x plus 4 times x plus 1, x plus 4 times x plus 1, regardless of the nature of the order they're in. So at this point, now that everyone has, so notice that every fraction, right? Every fraction has a denominator that is this x plus 4 times x plus 1. Even if it's in the opposite order, it doesn't matter, right? So I'm going to ignore the denominators. Now, if that's really bothering you mathematically, if you're like, Hogan, I feel like that's cheating, you could technically multiply the entirety of this equation by the quantity x plus 4 times x plus 1, and it would knock out the denominator. So if you feel the need mathematically to do that because you're stressing, you can, but you don't have to. So that means my numerators are going to be a 5x plus 11 equals 11, I can barely talk, equals an a times the quantity x plus 1 plus a b times the quantity x plus 4. So the thing about this equation is that it has to work for every x ever, because what we're trying to do is find fractions such that these fractions are literally always equivalent to this fraction. What that means is I can plug in any x's I want. So this is where we do that clever substitution thing, right? So I notice that if I were to plug in x equals -1, that's going to knock out this term. And that's going to allow me to find b. So if I plug in x equals -1, I'm going to get a -5 plus 11, right? Because -5 plus 11 equals bunch of 0 right here because it's an a times a 0, plus b times what seems to be, because I'm plugging in -1, a -1 plus 4, which is a 3. So it seems to me that I get 6 equals 3b, and using pretty basic math, I'm able to figure out that 2 is b. Now, since I know b, I could solve for a in a couple different ways. I'll be honest, the easiest option is to just say, you know what, I'm going to do clever substitution again. I'm just going to knock out b even though I know b. I'm going to plug in x equals -4, right? And if you're having trouble seeing why I picked -1 and -4, I essentially set this parentheses expression equal to 0 and solve for x. And I said, hey, if x was a -1, I'd get a 0 here. So when I pick -4, I'm going to get -20 plus 11, right, because it'd be -4 times 5, equals a times a -3 plus a whole bunch of 0, because when I plug in the -4, that gets knocked out. So I seem to have -9 equals -3a. Seems to me that my a is 3. Right? So once I know A and B, my last step, and it was the last step on this side as well, was to write the final answer, right? My final answer is that instead of A over x plus 4, it's a 3 over an x plus 4 plus a 2 over x plus 1. So what I've done now is I've taken this single fraction, right, this 5x plus 11 all over the x squared plus 5x plus 4, and I've rewritten it as these two fractions. It feels counterintuitive, especially the first couple times you do it, because you're so used to being told to put fractions together. But if you think back to what we were doing in Algebra 2 in Chapter 8, in Chapter 8 we were taking two fractions like this and we were adding them by getting a common denominator and then simplifying. So essentially, in Chapter 8 of Algebra 2, you were doing exactly the opposite skill set. You were taking these two fractions, getting a common denominator of this x plus 4 times x plus 1, and putting them together to get this expression. Sometimes when we get to calculus, we need to do the reverse, and that's what this lesson's about.